All right, so we are going to go ahead and finish up this note outline from yesterday, looking at some different types of problems and a couple of different ways you can kind of interpret how to solve them. All right, and so what we did yesterday was looking at the one-to-one property when we had a log with the same base on either side of the equal sign. So we use that property of equality saying, well, if we're saying that this log and this log have to be equal, that means that what we're taking the log of has to be the same value. So we were just able to kind of set those parts equal to each other, kind of like with the exponential property of equality. So now we're going to look at some examples where that's not the case. So here we just have log base 3 of 10x minus 9 equals 4. So we don't have a log on both sides. We've just got a log on one. So to kind of compare what we did on Monday with the solving exponentials. So again, when we had like 3 to the x equals 15, and we went to solve that, we said, well, if we are trying to solve for this variable x right here, and right now it's the exponent with a base of 3. So if we take log base 3 of each side, then we can use that inverse property that says when the base of the log and the base of the exponent are the same, they cancel each other out, leaving you just with log base 3 of 15. So now we're going to do the inverse of that, right? Because logs and exponents are inverses of each other. And so here, and there's a couple of ways that you can kind of see what's happening here. I'm going to show you guys both, and then I'll honestly probably like switch off so that there's a couple of examples of like both methods, and then you can decide what way you kind of see it better. And so for this first one here, we've got our variable, it's inside the log. And so again, a lot of people want to do this. Divide by 10x, or divide by log 3. But remember, log base 3 is nothing. If I were just to type log base 3 into my calculator, nothing would come up because log base 3 is an operation. It's not a numerical value. So in order to break this variable out of the log, I have to do the inverse of it. And so what I can kind of do is change it so that this quantity is an exponent. And whatever I do to one side, I have to do to the other. So now I can kind of think of this as 3 raised to the log base 3 power of 10x minus 9 equals 3 to the 4th power. So I'm just making it an exponent because now I can use the inverse property. I've got an exponent with a base of 3. I've got a log with a base of 3. They cancel each other out, leaving me with 10x minus 9 equals 3 to the 4th. Okay, now my log is gone because I did the inverse of it. And the inverse of log base 3 is an exponent base 3. So it's just the inverse. And so now if I change this 3 to the 4th to be 81, I'm just going to erase this to save a little bit of space here. And I can solve this from here. So 81 plus 9 is going to be 90. And the 90 divided by 10 is 9. We still have to make sure we check our answers here because we cannot have a variable value that makes our logarithm negative. So when I plug 9 back in here, 90 minus 9 is 81. 3 to the 4th is 81. So the other way that you can kind of start this, instead of like making each an exponent, is just kind of turning this into an exponent. So just like we did when we first introduced a logarithm, that was to change a logarithm into an exponent, you always start with the base and go around. So it's 3 to the 4th equals 10x minus 9. I'm not going to work out because you get the exact same answer. It's just a different way of kind of seeing it. So either taking this logarithm and changing it into exponential form, or using the inverse properties to make this and this an exponent. So now we can use the exponential property of equality and the inverse property to cancel those out. Okay, so like I said, I'm going to switch off kind of each method so that we understand how to do both, and then you can do whatever works better for you. All right, so in number 2, just like we did in number 3 up here, before you can do anything, whether it's the property of equality, whether it's changing it into an exponent, you have to combine all of your like terms. So you cannot do anything until these two logarithms are combined. So whenever we see that addition, we have to remember that addition and multiplication go together. So that means we'll do this over here. I'm going to have to multiply what's inside of the log. So it's going to be the log. Remember, this is really base 10 since it's not written in. And then that's going to be 2x squared minus 10x equals 2. So my variable is inside the log. The log has a base of 10. So to undo that, I could make it so that that is now an exponent, and I want the base of that exponent to be 10. And whatever I do to one side, I have to do to the other. So now those cancel each other out, and I'd have 2x squared minus 10x equals 10 squared, which is 100. I see this x squared right here, quadratic equation. So I'm going to subtract the 100 over. 2x squared minus 10x minus 100 equals 0. And then we're going to start this one by actually dividing by 2, right? We want to try to get a to be 1 if possible, and we can do that here because everything is divisible by 2. So if I simplify that, that would give me x squared minus 5x minus 50 equals 0. The two numbers that multiply to negative 50 and add to negative 5 would be negative 10 and 5, which would make our possible solutions 10 or negative 5. So now I'm going to come back up here. I'm going to plug each value into each log to make sure I don't get a negative value inside that log. And remember, you always come up and you do that in this first step right here. So 2 times 10 is 20. 10 minus 5 is 5. I get a positive here and a positive here. So that means 10 is good to go. And then 2 times negative 5 is negative 10. Can't happen. I want to reiterate, that doesn't mean that you can never have a negative answer. It just happens that this negative answer, and negative answers a lot of times will make your log negative. Okay. All right, so we are going to kind of do now the same thing here. Remember, these don't cancel each other out because the 6 is being multiplied by that x. So if that x had been a power, that would be different. 6, though, is not the base of an exponent because it's 6x. So we're going to start by doing the same thing we did in this one. I can't do anything until I have combined these two logarithms. So 6x times x minus 1, it may help you kind of see that next step better. Don't forget, you still have to keep it as log base 6. So log base 6 does not disappear. And then when I multiply the contents of the log, that would be 6x squared minus 6x equals 2. So now I'm going to do this one kind of the other way. So instead of writing this equation as a logarithm, I'm going to write it in exponential form. So always start with the base, work your way around. So 6 squared is equal to 6x squared minus 6x. I find that most people do like this method a little bit better just because it's more similar to what we did with the exponents on Monday, but it is totally up to you. Again, see this quadratic guy right here? 6x squared. So I'm going to move the 6 squared over to the other side. So minus 36. Luckily, these three terms can all be divided by 6, so that's going to make the factoring a lot easier. So that turns this into 1x squared minus 1x minus 6. I'm looking for two numbers that multiply to negative 6 and add to negative 1. That would be negative 3 and positive 2, which would make my two possible solutions 3 and negative 2. Then I plug these back in. 6 times 3 gives me positive. We're good there. 3 minus 1 gives me a positive. We're good there. So that should work. But when I plug in negative 2, 6 times negative 2 is negative 12. So negative 2 will not work because you cannot raise 6 to a power and get negative 12. All right, now let's look at number 4. So what I might have you do is first I need you to change this to a 6. That was a type, or 6 to an 8. I apologize for that. And then why don't you pause the video and try, kind of pick one of the methods and do that one on your own. Okay, let's see how we did. So now I'm going to do this kind of the exponential way. Raise makes this, so if my log is base 2, I'm going to make it so that both sides are now the exponent with a base of 2. Because now the inverse property tells me that those cancel out. So I get x squared minus x minus 8, 2 squared is 4. Okay. All right, I've got quadratic again. So now I'm going to subtract that 4 over here. We always want to keep our x squared term positive. These factors will be x minus 4 and x plus 3, which means that x can either be 4 or negative 3. So now when I plug these back in, make sure I don't get a negative. 4 squared minus 4 minus 8 gives me 4, so I'm good there. And I know 2 squared is 4. Negative 3 squared, so make sure you put that negative in parentheses because that could affect your answer. Minus negative 3 minus 8 also gives me positive 4. So here's an answer where the negative works. So now this particular equation has two solutions. It's either 4 or negative 3. So that's why you have to be really careful that you're always checking your answer and not just assuming that because it's negative it won't work. Okay. All right, we've got just kind of 2 more examples, I think. Yep. All right, so now here's one where we're going to be using natural log. And so we have to remember that the base of a natural log is e. So if we make that e and we change that into the exponential form, we would get e to the 5th equals x minus 2. Or again, make it so that each side becomes an exponent with a base of e. It's the same idea. As long as whatever you do to one side, you're doing to the other. Now you have to remember that e is not a variable. It's like 2.7. It's an irrational number. So that means all I have to do to get x by itself is add 2 to both sides. And then when you type that into your calculator, we're not typing in, a lot of people will type in natural log of 5, but it's not natural log of 5, it's e to the 5th. They are different. And so we would need to hit second natural log to get that e. So e to the 5th, close the parentheses. Now we're adding 2 to that. So that's going to be about 150.413. And that would be my answer. Okay. All right, so this last one, I kind of see something that we can do to make this a little bit easier. And you always want to make sure you're kind of looking for these. And I'll explain to you the difference between why we can do this with one of the terms but not the other. So on the front, we had several problems like this where our first step was to multiply the contents of the logs together. But here, I see a case where I can change this so that it's not a log anymore. So remember, we want to be able to picture logs as exponents. And this is really 3 to what power is 3. So that's just 1. Again, I cannot do that here unless you wanted to split this apart, which you could do. But since the 3 here is attached to the x squared, you can't just cancel those out like you can here. If you split that apart using properties of logs, then you could. You'd have another case where you had log base 3 of 3. I'll kind of show you that. Whoops, I forgot the 3. Plus log base 3 of x squared plus 1 equals 2. Now you can make this a 1 again. So then if we combine those like terms, 1 plus 1 is 2. Now we kind of have a different equation to solve for. So now when I subtract 2 from both sides, I actually get 0. And so now we have to be careful with that 0 because a lot of people say, oh, no solution. So if we work through this one a little bit farther, I'm going to make it so that they're both exponents. So 3 to the log base 3 of x squared, 3 to the 0. So those cancel. Remember, 3 to the 0 power is 1. So it's not no solution. And then our answer here, if we take the square root of each side, would be positive or negative 1. Anytime you solve a quadratic, you have 2 possible answers. And in this case, when I plug the negative back into my original problem, it's going to become positive. So both the positive and the negative answer will work here. Now, because of kind of some of these special cases, there's a lot of different ways you can solve this. If you kind of started working ahead or did some other things to solve it, as long as you get to positive or negative 1, you're good to go. I would not expect probably the majority of you guys to split this apart and do this trick. It's just kind of nice when you see that. It does make a lot of the algebra a little bit easier, but a lot of it's just kind of depending on what you see in the problem. So your assignment tonight is to finish this worksheet. So all the ones that you did yesterday had a log on both sides. The ones that you are doing today are like the ones we just did in this video. And then tomorrow you'll practice everything from this week, and then another quiz on Friday, and then it is spring break. Well deserved. So as always, email me with questions or come to Canvas conferences.